This is the video going over the Chapter 9 free response review. Okay, so question 1 was a one sample situation, and both questions are just an SPDC problem. Okay, so I just kind of had to read the problem, wrap my head around it. It sounds like the claim, so this is telling you about your hoe. That's the null hypothesis we're testing against, testing to see if it's true. Anyway, so that's 20%. They gave us a p hat, 11 out of 65 is 0.17. And I drew a little picture here to keep my wits about me here. So 0.2 is our null value, our hoe value, and our sample was 0.17, so that's below it. And we're interested to see how extreme is 0.17. So what is this little blue shaded area down at the bottom as a way to quantify how extreme 0.17 is compared to 0.2? Okay, so it's essentially the SPDC problem. With these problems, they don't always, this is actually how the College Board grades it, and they don't always grade every little detail. Some of the things, especially the things that they felt like were just obviously stated in the problem, they don't bother grading. So for the part A, the state part, here's your hoe and your ha. They do need that. And then they do want you to define your parameter. So this is the state. Here is the plan part. So they need you to identify the correct test. They said by name or by formula. So if you say one sample Z test for a proportion or for P, you're good. On a side note, if you also included the equation, they would still give you credit for having the right procedure. But we're in the habit of doing both just to cover our bases. For the conditions, it looks like they didn't actually grade for you stating that it was random because they felt like that was obviously stated in the paragraph, so they just didn't bother grading it. They did grade large counts. So here's their large counts calculation. They graded the 10% thing. They did it by saying if 65 was your sample size, multiply that by 10, you get a limit, a minimum on your population size for everything to be okay. And they say it's reasonable to assume that they produce more than 650 boxes of cereal. And then they also mentioned that they're independent. Okay, then here comes the do part. So here's your p hat. Once you plug it through the equation, you should get a Z, a test statistic of negative 0.62. And then if you go to table A, you'll get your p-value of 0.2676. Now, in this key, they're just kind of giving you the numbers because remember, this is their grading key. I do want you to show your work on the test. So show the equation, show the general equation, show the equation with variables, plug in the numbers, show it with the numbers plugged in, and then calculate it. So show all of your work. That really, really helps me give you partial credit if something goes wrong. And even if you're convinced that you did it right, still show it to me anyway. I will take off some points if you're not showing your work. Okay, and then here's the conclude part. So since the p-value is larger than the alpha, we cannot reject the hoe. They said statistically significant evidence, but we're saying we do not have convincing evidence, same thing, to support the ha, the student's belief that the proportion is less than 20%. All right, that's it. Now we'll go, oh, and then as usual, for whatever reason, when this prints out, it prints it out twice. So skip for problem 2 all the way down to page 6 on the PDF to get to problem 2. Okay, so I kind of take back what I just said. So page 6 is where number 2 starts, but where it actually becomes useful is down on page 8. So this is the version we've done in class. There's more than one way to do this problem. The other way is something that we're going to learn at the very end of the year, and we just haven't learned it yet. So they left the rubric pretty open for them to judge it either way. But this is the way we've done it in class so far, where we have a hoe and a ha. This is our state part. That's a T. And we defined a parameter. And then they figured out their p hats. Also, they didn't include it in here, but you should figure out your p combined, your p hat combined, because that does come into play down here. Okay, so for their conditions, they only graded them on large counts, and they didn't even make them show the calculation. They just said both samples are large enough. Okay, so that's the large counts thing. And then here, so this is the plan. And remember, in their rubrics for the AP people, they're okay with you naming the procedure. They're also okay with you just giving the equation as a way to name the procedure. If we were to name the procedure, we would have said it's a 2-sample z-test for P1 minus P2. Yeah, so state that and do the equation. So for me, I want you to do both. For the AP graders, if they see either one, they're okay. And on this rubric, they just wrote the equation. This is a pretty thin rubric they're giving here, is the truth. So for conditions, do the large counts. You should also, for me, write out that they said it was random and write out the 10% rule. It sounds like on the real AP test, they didn't grade for those, but I want to see all of those. I want to see everything. Yeah. Okay, so here's the equation. Now, this is a slightly different version of the equation than what we saw in class. This is the one that does show up on the AP formula sheet, and it's just a slightly rearranged version. These are just PCs, and all they did was they factored out the numerator of those fractions. And anyway, it's a slightly rearranged version. You could use the version we've been using or this version if you wanted to, but everything's plugged into the equation. And here is their test statistic. This is their Z value. Now, remember that our HA is a greater than. So for 2 samples, it's always centered around 0. So if P1 is bigger than P2, another way to say that, P1 minus P2 is greater than 0. So we want to be greater than 0. Or just remember that as long as you go in the order of 1 and then 2, it still matches. So greater than is the upper end. So because we're interested in an upper end, we need to do 1 minus the number we get out of table A, and here is our p-value. So this is our do, and then here is our conclude. And they did not use the exact sentence frame that we've been using, but it, says the same thing. They said, well, okay. They said, well, the proportion of voters in the sample supporting the candidate after their unfortunate remarks were made is less than the proportion of voters from before. So the reviews of this candidate did get worse. The difference is not statistically significant and can be reasonably attributed to chance. So another way that we would say that, because our p-value of 0.14 is greater than our alpha of, did they give an alpha? I don't think they did. Sorry, I should have checked this. Yeah, so if they don't give you an alpha, just default to 0.05, but make sure you state that you're doing that. So somewhere up here in state, you would say alpha 0.05. Okay. So because the p-value 0.14 is greater than alpha 0.05, our p is not low, right? So we do not reject the HO. We fail to reject the null hypothesis. We do not have convincing evidence. They say statistically significant evidence. Means same thing. That the HA. So the HA is that voter support, I don't know, I'm going to say decreased after the unfortunate remarks. You could phrase that lots of ways. Okay, so that would be a conclusion that would match our sentence stem. Okay, that's it. Sorry, did not realize that was still recording. Now I know and I will turn it off.